Hi, my name's Jack. I'm a psychology and language science graduate from University College London, and I teach psychology and biology. I thought I'd use this profile video just to give a quick demonstration on how to choose a statistical test. You need to first decide whether you're looking at scores or frequencies. So in other words, if each participant has an individual score, or if you are just sort of collecting data, for example, for days of the week. If that is the case, then you should use a chi-square. Now, scores are a little bit more complicated than frequencies. You need to assess a couple of things. First of all, you need to assess whether you're looking at two-sample or k-sample. So in other words, are there two conditions of the independent variable, or are there more than two? So you might have A, B, C, and so on and so forth. Now, the next step after this is to look at your experimental design. Is it independent groups, so between subjects, or is it repeat measures within subjects? Each one warrants a different statistical test. Now, you then need to decide whether your test meets parametric assumptions. So does it meet the assumptions for parametric tests? Now, there are two assumptions that really it must meet. So it must have a normal distribution and the data must be scalic. If it meets both of these assumptions, then in the case of a two-sample data, you would use a parametric t-test. If it was between subjects, that would be an independent samples t-test, and if it was within subjects, it would be paired samples. Okay, now if it doesn't meet those assumptions, and I'm sorry the writing's just gone off the board here, but if it doesn't meet those assumptions, then you're looking at a Mann-Whitney for a between subjects and a Wilcoxon within subjects. Now if your data is k-sample, if it meets assumptions, you're just looking at a simple analysis of variance, and if it doesn't, then you need to choose between, depending on the experimental design again, a Kruskal-Wallis, or if it's within subjects, a Friedman's test.